if we have a series like this one, 1 plus 2 plus 4 plus 8 plus 16 and so on, where the ratio between successive terms is a constant. If that happens, then this is called a geometric progression or geometric series. So the ratio is, in this case the ratio is 2, and when that happens we can write a formula for the nth term, and that will be, if we write the nth term, that can be written as a r to the power n minus 1. Now a is the first term, in this case it's 1. So from here I can write the fifth term. Let's say the fifth term will be 1 r is 2 to the power 5 minus 1, that is 4. So 2 to the power 4 is 16. So that's the fifth term here. And to get the sum of such a series up to n term, the expression is sum is a r to the power n minus 1 divided by r minus 1, provided r is greater than 1. Like in this case, r was greater than 1. We can have a series where r is less than 1, because if, let's say, we have a series 1 plus 0.5 plus 0.25 and so on, that means r is half or 0.5. So there, here r is less than 1. If we have a series where r is less than 1, the sum of the series is a 1 minus r to the power n over 1 minus r, because with this formula it will get negative. So the expression for the sum when the r is less than 1, this is the expression. And if we have a series where it goes, we can have a series up to infinity when r is less than 1. If r is more than 1, it cannot go up to infinity, because then it will reach infinity literally. But when we have a series where r is less than 1, it will be less, and finally it will become very insignificant. The term will become very insignificant. So we can actually calculate a sum for that case, and that sum is s a 1 minus r. We can actually derive this from this expression, because when r is less than 1 and when the n is very large, because when it approaches infinity, n is very large, theoretically infinity. When it approaches infinity, so r to the power n will be it will be 0. It will be very, very small, so very small, less than 1 or approximately 0, because r is less than 1. It's a fraction. So r to the power n, when n is very large, will approach 0. So we can ignore this part, and if we can ignore this part, this will be the sum infinity when r is less than 1. Only then we can have a series with infinite terms, and the sum is given by this expression.